Okay, I think we're live. So, I mean, I didn't stream yesterday, but I did get my debugger working finally. Whoa. Oh, I missed the best far. Yep. And I can finally see all my memory and local variables. It is okay, yeah, which is awesome. It wasn't too bad. I just had to switch to GTB. And I did see it had something to do with Visual Studio, so I thought I should probably get that working first. Alright, see what this is about.
Clean one to upload to YouTube. And there we go. All right, welcome everybody to what is day 16. You didn't think we would make it to such a high power of 2, but we did. Day 16 of Handmade Hero, the show where we actually code an entire professional quality game from scratch so that we can basically explore all of the intricacies of what a computer does when it runs a game, so that we can basically see and understand everything that is going on. So we don't use any libraries, and we try to kind of get down as detail-oriented as we can to try and basically tease out all of that stuff that's kind of obscured when you use higher level stuff. And so far we have done the Win32 side of things, where we've just made ourselves basically an interface to Windows that allows us to do the sorts of things we need to do in a game. And we're almost to the part where we're going to actually start building the game proper. What we're going to do this week is basically transition between those two. And so in order to do that, what we need to do is go through our Win32 code and clean up any of the stuff that we haven't finished yet. Just touch things up, go through any of the stuff that we didn't have time to do. There's just some loose ends that were left hanging when we wrote everything. And so that's really what's going to be our focus today, is going through and making sure we kind of like get that done. And we'll do that for the next couple days until we're satisfied that everything's in good shape, and then we can move on to just game code proper. Now, for those of you who have pre-ordered the game from handmadehero.org, if you are following along with the source code at home that it comes with, you want to unzip day 15, because that is the source code that I am starting with. So if you want to follow along, unzip day 15 from the pre-order, and that will be where we are starting. All right, so let me go ahead and jump in here. The first thing, excuse me. Yeah, it's been a long, cold winter here for me. As you know, in every stream, I'm coughing just a little bit. Getting better, but what can you do? It's definitely going to be one of those winters where I'm sick all the time, but you know what? Sickness doesn't really have to stop me programming most of the time. Thankfully, I have not been that sick yet. So hopefully things will continue where I can stream with just a little bit of coughing. Anyway, so one of the big things that I said we were going to do, and which we hadn't done yet, but I'd like to start doing now as we sort of move forwards, is one of the things that we're doing in our build script here is we are just compiling with no real warnings turned on. Like we only have the barest minimum warnings turned on. And warnings are basically things that the compiler doesn't actually need you to fix. It doesn't need you to fix warnings. It can still generate the code just fine, but it does tend to indicate that there might be something wrong. So warning is the compiler's way of telling you, hey, I'm not sure about this. It looks like something that might be suspicious. Could you check it out? And that is basically what a warning is. And so one of the things that I want to do is I want to turn on warnings in our compile. Basically turn on a higher level of warnings. Warnings are typically grouped into levels, level 1, level 2, level 3, level 4, and so on, such that you can enable them in waves, and they're sort of categorized so that you don't have to enable like each individual warning. So typically what you'll do is you enable a certain level of warning that you're comfortable with. In this case, we're probably going to use warning level 3. And you're going to enable that warning level, and then you're going to disable any warnings that you didn't want from that warning level. That's a lot easier than picking each individual warning and turning it on. Now what'll happen, you can see, if we actually turn on basically all the warnings, right? If I do -W all, we get some pretty immediate problems, some of which we can fix, and some of which we couldn't fix.
I wonder if... what's the word? Yeah, Zig has the same. Oh, where would I find it? Maybe here? I don't know what's wrong with my font since Chrome got updated. Right, it's cross-platform dependency free way to declare logic required to build project. This system, the logic is built. The logic to build a project is written in a build.zip file. Some examples depending on other projects, providing a package for other projects to depend on, creating build artifacts by executing the zig compiler. This includes zig source as well as C++ source. Surfacing build configuration as comtime values. What is run zig format? Well, I don't know where to run that. / main. What does it do? I don't know. Build artifacts, blah 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 blah. To use the build system, run zig build help to see command line usage help menu. Install, uninstall, run, test. What are we looking for again? Similar flags, warning flags. Quimo. What is Quimo? Rosetta. Heard that one before. Not sure what that is either. Was time. No idea what that is either. Doesn't seem very useful. Print commands before executing them. Error messages. Limit concurrent jobs. Limit memory usage. Delay before rebuilding after change file detected. Oh, there is a watch mode. I had no idea. That's pretty cool. try that. Make, build, run. Oh, that's pretty cool. If I save it, yeah, nice. Oh, that could be handy. Let's say, where's the buffer? Print. Why is it so quiet? I have no idea. Key press, render, here. Let's do x squared plus y squared. Okay. Hey, that's pretty cool. I like the watch mode. Let's see. What else have we got? Watch, debound, web UI. Enable web interface for on the given IP address. Fuzz. Continuously search for unit test failures. Time report. Target, CPU. What's this? Target object format. Dynamic linker. Optimize. Guess in zig build run is debug mode. Deoptimize equals debug. Type built-in.optimize mode. What is built-in.optimize? Okay. Let me check if I... Does it not take a command? Free external console. Maybe not. Okay, what else we got? Hey, sushi, slushy. What are you making? I don't know yet. I'm following along Handmade Hero at the moment, and we was just adding build flags to see, I think to see errors and warnings. So I was just checking what's available in Zig. So I was just going through the help command. As to what I make, and I don't know yet. It depends on how Handmade goes. System integration, F reference trace, table reference line, override path, cache. For shuffling dependency traversal. Embeds a build ID in binaries. Okay, I had no idea. It's pretty cool. Debug log, enable debugging the compiler. Let's see what happens there. Big build run. What is the value it expects? I do see a scope here. Don't know what that means. Debug package config. Fail if unknown package config flags encountered. Debug compiler runtime libraries. Linking output for sync air. What is that? This is new. What is ZSF? Oh, Zig Software Foundation. Let's see. There's no mention of it. Enable compiler debug output. LVM IR. I think I knew what IR was. I don't remember anymore. LVMPC. What about CC? What's that? C compilation. Okay, I mean, I don't see any other flags. I did find one. What? Pretty useful. Okay. I think I can carry on.
So for example, you can see in here, it's going to warn us about some things that maybe we did want to know about. Like for example, it's telling us that there's going to be padding inserted here because this is a 32-bit value and this is a 64-bit value. Now that's a warning I wouldn't mind seeing, warning 4820. That's can be useful, it's educational for me. In case I forgot that when I wrote the struct, right? It's kind of just nice to know. Doesn't mean you have to fix it, but it does mean that it's just a nice thing to know. But as you can see, when we get down into these other warnings here, there's just a stream of them that are all in windows.h. They're in Windows' header files, right? Just reams of warnings in Windows header files. So there's not a lot that we
Hey, Fluffy Unicorn. How you doing?
could really do about that, short of getting rid of Windows.h, which could be something that we might want to do, like I've talked about in the future. I don't know that we're going to do it this week, but we might do it in the future. So we could get rid of that, but the saner thing to do potentially will just be to switch down to a warning level that can, sort of successfully.
Yeah, I'm good too. I just got my debugger to work again on Visual Studio. Yeah, it wasn't working after I updated Zig. But I switched back to the GDB debugger on VS Code and it works now. So happy days, I guess.
Go ahead and compile the Windows header files just to keep that out of the equation for now. So what I did is I dropped down to warning level 3. Warning level 3 has really no problem. I don't know if warning level 4, I don't think warning level 4 can. Oh, so warning level 4 can compile them as well. It's just not if you turn on all of them. So we could consider turning on warning level 4 as well. 3 and 4 will both work, just not all, which is, I guess, above 4 if you think about it. So, my apple is done. I'm getting all those vitamins. I don't know if apples have vitamins. Maybe apples have vitamins. Hard to say. Anyway.
Definitely, who does?
Couldn't leave that one piece lying there. It was too hard to do. So, moving along. Basically what we can do is we can now look at the warnings that we do have in our code. And the ones that we agree with.
Oh yeah, I think there's quite a lot. The latest one, 0.15. And there were a lot of breaking changes because they moved async to the standard library. But they did make reading and writing files like very simple. It's like Go simple. I mean, as simple as it go. Because they introduced the generic interfaces, writer and reader. So yeah, there were a few breaking changes in this release. I think there's going to be some more because they are going to remove the old await from a lot of places in the standard library.
We can basically fix whatever it was that was causing the warning, and the ones that we think are just annoying, we can turn off. So we can basically decide at this point what warnings we want and what warnings we think are busy work that the compiler is just telling us to do that we don't want to do. Now another thing we can do, and I'll do that first, is you'll notice that if I compile this here, basically the compile succeeded just fine, because warnings do not stop the compile. But what you can do, I believe it's -WX as well, another command line switch you can do. I believe you can do, WX. If you pass WX, it will basically treat warnings as errors. So it's basically the same as saying like, okay, warnings just are errors. They're things I'm either going to turn the warning off if I think that it's an erroneous kind of warning, or I'm going to fix it. But I don't ever want you.
Is async working? So far, I haven't tried it. Since they moved it to the standard library. But I do need, well, I don't know. I haven't needed it so far, so no idea. But to be fair, the only thing that didn't work was LLVM, because I think they're planning on removing it as well, if I'm correct. Yeah, no, don't worry about it. That was the only reason I picked Rust in the end. It was Rust had hit 1.0, not that Rust is complete, it still gets new features. The core of the language is settled. If Zig was 1, when I was making that choice, I may have gone with Zig. It's more C like, more familiar with C. Yeah, I think fair enough. And then for me, it didn't matter that much because I only use it for building side projects. So I didn't really mind that it wasn't 1.0. I just wanted to like try something low level. So it was either C or Zig. Rust was too scary looking. It was like, yeah, especially for side projects. Yeah. I mean, to be fair to Rust, I've never tried it. I think one of my work colleagues at one of my previous places, he did a demo of Rust because he was a big fan. Yeah, he didn't do a very good demo. Because all it was like, it just made me not want to program in the language. But I would probably try it for myself once.
To actually let me compile this file into an executable if there's warnings in there. And I think I want to do that as well because we're going to be basically keeping our warning set to just warnings that we consider useful and important.
Yeah, that's what I noticed too. It is completely different. And with Zig, there's a lot of similarities with Go. And I use Go for work. So it was a lot easier. Yeah, Go is really cool. I like Go too.
We're going to turn off ones that we think are frivolous. So at that point, it doesn't really make sense to ever allow them to be in there. We should just never have any warnings because if there were ones that we really thought were frivolous and unimportant, we would have turned them off. So that's the way I'm going to treat it for now. So I'm going to leave that WX in there. So if we look here, now what we get is basically this guy right here that I said I wanted to use the nameless structure. This guy. It doesn't love that guy because that's apparently something that it doesn't think is a standard sort of extension. It doesn't think that's a standard way to do that. But I don't think that's actually a
I think I could skip ahead for this one. None of these really apply. To say configuring for a 32-bit build. Should that? I don't know. Windows XP virtual machine testing. Let's look
to
at
kind
that.
of let you know that. So basically, what I wanted to show you is minus MT instead of minus MD is the thing that's minus MD says use the DLL, minus MT says use the static library, like link it in, actually package all the C runtime library into our executable wholesale. Don't look for a DLL. That is the switch that you absolutely want to have set so that you don't get that error. And then when you run on another computer, you don't need
So at XP, yeah. I haven't seen XP in so many years.
to have that VC vars redistributable.
That takes me back. My first computer was an XP, I think.
So that's a very good thing if you're trying to make your game more compatible. So basically now at least we know we are running sanely. We can run on Windows XP. I hear the sound. We've got the image and everything. So I think we're in pretty good shape.
Yeah. And then from like a nostalgia perspective, when we'd see this background and everything, I hadn't even changed the background for a long while. I didn't know how, so I just left it. Yeah, pretty cool.
That's all I really wanted to show you. And so I keep a virtual machine around or an actual machine installed with Windows XP for this very purpose when I actually want it. I'm going to actually just get rid of this now. Let's see, power off the machine, I guess, because we don't need it for anything else. But that's all I wanted to show you. And so I'm going to put that in there, even though it's the default on the command line.
Is it this? Is that a similar? I did see something. Verbose compiler debug output. Not really. Oh, I don't even know what that is. Windows 3. Ink system library. I mean, the end result is a binary, so I'm guessing. What does this do? Oh, it takes in options. Oh, that's interesting. X11, I could mark it as dot needed. Because I think it won't work without. Oh, sorry. Really? Oh, it's a struct. Thought it was an enum. Yeah, it is pretty cool. And I mean, it's so easy to link like a system library. That's all you have to do. And then when you use it, for instance, let's say, yeah, here, it creates like the zig bindings for you as well, which is pretty cool. What other options are there? And false dynamic libraries with no reference symbols will be omitted by the linker. I mean, if it's false, why would you even link the library? No idea. Pulse, pulse audio actually is optional. If it's not there, it's fine. What does weak mean? Marks all reference symbols from this library as weak, meaning that if a same named symbol is provided by another compilation unit, linker will dissolve all reference to the symbol, the strong version. And the linker encounters two weak symbols. The chosen one is determined by the order of compilation provided to the linker privacy given to later ones. I would turn that to true. Because if pulse audio doesn't actually exist, I do need to provide like a stub function or something else in its place. Does still run? Okay. And gotta change my. I still gotta add the offset. Oh, it still works. Oh, but I don't write the audio. Okay, that was easy enough. Oh yeah, I wanted to check. What's it called again? Link system library. Build system. C import and Zig translate C use the same underlying C translation functionality. So on a technical level, they are got me second guessing if I should use Zig. If I made my hobby engine in Zig, it would be one of the first libraries for Zig, and I could maybe use that as marketing, even though my engine will probably end up open source. I mean, I'm not telling you not to do it. Translation functionality. Well, in practice, C import is useful in a way to quickly and easily access numeric constants, type defs, and records without needing any extra setup. If you need to pass C flags to Clang, or if you would like to edit translator code, it's recommended to use Zig translate C. I'm guessing this is different when you, let's say, results to a file. Does this mean I could write the pulse audio bit in C and just use translate C? Because I couldn't get the async to work with Zig. Common reasons for editing generated code. Or specific types. Okay. I mean, not really. It's fine. That's excuse me. For the runtime, I look into Zig. One thing I love about Zig is the any with integers. I'm building Unicode encoder slash decoder, and really all I need is 17 bits at any given time. I used to be even more efficient. Hey, nobody. I think we're all nerds here. So I guess it's too late for that. Oh yeah, but I'm pretty sure I think Rust would have it too, right? But I mean, using U17 would be kind of weird though. 17 bits. Okay, sorry. So that's like 2 bytes. No, 3 bytes. Around 3 bytes. Oh yeah, so it would be a U17. Okay, moving on. Okay, empty wine is empty. I still don't know. I think it's linked, but I mean, I'm just guessing. I don't know where to check. Yes, cloud. When linking system libraries in Zig is a part of the final build, final binary, like D dash and T flag in C. Static linking. Okay, I did see that flag though. Unfortunately, not. Rust has a different philosophy. Rust focuses on creating correct software which will last for a long time. Okay, I mean, I do like that though. Software that lasts for a long time. What's it again? Delinkage. Excuse me. Don't really see that. This feels like you're solving a tedious problem. The tick to me felt fun to write. Therefore, being fun, write faster and more. Okay, fair. You're saying Rust is not fun to write. I guess you are. I mean, but to be fair, like people have been writing programs in C, like the library that I'm using here, X11. I think it's from the 80s, and it still works. I mean, and it is quite a long time, to be fair. At least for a software project. Yeah, and it still works. Um, where is it? Yeah, right here. Like, it works very well. Static linking. I think this is a made up flag. doesn't exist. Those failures. Detail. Okay, this seems. Oh, I lost it. Yep, here. CPU. Target object format. Interesting. Path to interpreter on the target system. Static linking. Some percentage support I can see why it's okay. These are the C build commands. Hmm. Alright, moving on.
So I don't think.
Hang on. Let me write to do somewhere so I don't forget. Check linking static linking options at some point.
You would ever have this mistake if you were using the command line, because even if you don't specify it, it's fine. But in the IDE, I believe when you create a new project, the default is to use the multi-threaded DLL, and that's really bad. Like, you don't want that. It creates all kinds of compatibility nightmares for you. So that's basically all I wanted to cover, I think. That's basically everything I had written down here that's not about compilation. I guess I wanted to turn off minimal rebuild since we're building, we rebuild everything every time. Minus GM minus turns off any sort of incremental build stuff that Microsoft might be trying to do to quote unquote speed things up since we're not doing any of that kind of rebuilding. And I think that's about everything there is. Now, I did want to produce one more thing since this is, like I said, a stream about kind of learning how all of these stuff works. There is one more thing I wanted to do since we've got plenty of time here. It's called minus FM. Minus FM allows us to basically pass something that tells the tells the linker a location to stick a map file, basically. So if I do this, right, I will now get an extra file in here where I actually build my game, right? So you can see that before there wasn't this thing, this map file. There is now a map file, and the map file is kind of interesting. You can see if I actually just, oops, that's not. All right, if I go ahead and take a listing of the executable, if I look at the map file, what the map file actually is it's basically what exactly its name. It is a map. It is a thing that tells you in text form where all of the functions are in your actual executable. Like you can actually see every last thing that is in there is actually listed, right? It's like here they all.
Can I get that in here? I didn't copy nothing. Zig build map file. Let me check if there's anything zig out. BIOS Bob. I like that name. Okay. Without invoking the linker. Build, fetch init, run test, ASD check, archiver. I mean, yeah, obviously, right? That is a big. I mean, it's right. It might take me 3 months to feel as comfortable as I do with Rust, with Zig. Yeah, but if you know Go, it might be a bit easier. But there are like certain things it takes a bit of getting used to. And if you're like short on time, I'd say like, I mean, see it through the current project, and then maybe in the next one you can consider Zig. How far in are you with your engine? List available compilation targets. Object copy. Whoa, whoa. Why is it actually running? What is it? Okay, what will it do? Oh, okay. I mean, in that case, I think you can still, you could do like a, I mean, whatever you've done in the last week with Rust, you could see how much time it would take with Zig. Considering you don't, you're not familiar with it. I mean, it's only a weekend. I'd say give it a shot. Come on, just come on, blah, 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 blah. It just runs it though. Oh, we keep debug. Yeah, or try Zig with something else. Doesn't have to be on your main project, right? You could try, if you just try it on the side, something simple. Hey, no worries. I appreciate the distraction. Because I don't really know what I'm looking for. Okay, so I need to use... Okay. It's not that important.
Here's where everything went, right? All the stuff that we actually wanted to know where it was, it's in there. Now, one of the things is you might ask, why do we actually care where any of this stuff is, and why does it look so funny in some of the places? You can see some of these have some really bizarre stuff on them and that sort of stuff. Well, basically, there's a bunch of subtleties with map files. Basically, excuse me, what happens with a map file is it's going to go ahead and, we can actually see, looking at the side, if you look at the side here, you can see what module was responsible for outputting something into your map file, and then what the thing was, what the name was of the thing that got outputted, and you can also see where, like this is basically the byte offset of the actual thing, where it actually was, these sorts of things. But what I wanted to point out is basically there's a lot of what's called name mangling that goes on in here that might be confusing to people. So if you look at some stuff like this sort of thing, the names just look absolutely crazy. Like that looks pretty normal. It's got a lot of underscores, but underscores are usually just saying, hey, this is a reserved keyword in C. So a lot of things will have underscores in them if there's something the compiler used or introduced, right? But these things here, right? These sort of weirdly mangled names, those are kind of an interesting anachronism, and it's worth understanding what they are. So this map file, I'll talk about those in a second, but I just want to finish up. So this map file is basically just a thing, if we kind of want to know what ended up getting put in our executable and where stuff is, this is a thing that basically just is a text file that tells you exactly that information, and it's kind of fun to be able to look at. And you can even see, remember I said we were using an import library to basically allow us to bind to DLLs, system DLLs. Well, you can even see what those kind of are. You can see this underscore underscore imp underscore underscore write console W, or underscore underscore imp, like where's one that we actually call, like get file size, there it is. And basically what that is that's an import function that was the thing that was put in place as sort of a stub, essentially, that's going to be replaced with the actual pointer to the Win32 DLL when it gets loaded. So you'll see underscore underscore imp versions of every Win32 thing that either you call or the C runtime library calls, and therefore needs to bind to. So a lot of these things we don't call, but the C runtime library called, so they had to get dragged in. And that's one nice thing too that you can kind of see when you start looking at the map file. You can see all the stuff that got stuck in there that you didn't even necessarily want or know about, right? There's just tons of stuff in there that you didn't necessarily want, that you don't even necessarily call. And it's just kind of interesting to kind of be aware of it, that like, oh, the C runtime library dragged that in, or such and such happened, right? And you can get rid of some of that stuff sometimes. There's basically a thing called opt-ref, which you can do, that you can pass to the linker, which basically says to be aggressive about not putting anything. You do it this way, opt-ref, like that. If you pass that to the linker, it basically says don't put anything into the executable if you don't need to. Like if nobody uses it, make sure you get rid of it. It's kind of like try hard to discard things, if that makes sense. And if we take a look at what happens when we specify that, you'll notice it went from a 157K to 142K. So it does, to 134K. And so it does get rid of some stuff. There is some stuff that gets stuck in there that doesn't need to be because no one actually called it or used it.
Let's see something similar to that before. Was it in build? There's like linker options. Here. When is a weak symbol filled with the, no, not the same. Ah, okay. That's what I was looking for before. Preferred link mode. Preferred. Is that a typo? It's 2 R's. Okay, what does that look like? Okay. That doesn't look good. Why did it fail? XCB disconnect. Okay. Might leave that out for now because I don't understand the errors. Static linking. Maybe I can. It's really old though. I was gonna let him know.
Or whatever. But there's still just a ton of stuff used by the C runtime library that is just stuck in there. And that's unfortunate, right? It's one of the reasons to get rid of the C runtime library if you can. And we talked a little bit about maybe doing that. I've done it on projects before, but I don't know how productive it would be to spend time in the stream to do that, so we probably won't. Anyway, on to the name mangling. So the way name mangling works is basically C used to have sane names for things. When you used to call things in C, they used to look like this. They would look like just the name of the thing that you called. But the problem is C++ introduced overloaded functions. Now I've talked about what that was. I showed an example of that on the stream previously. Basically what an overloaded function is an overloaded function is having two functions with the same name, like this, but that take different parameters. right? This kind of thing, right? Basically what this is trying to say is, all right, I'm going to call foo, and then I want you to call whichever foo happens to be the one that uses the parameters that I passed. So I might say foo5 or foo56, and this one will call the second foo, and this one will call the first foo. It's as if they were labeled like this, right? Does that make sense? So the problem here was that C++ was originally written sort of on top of a C-like toolchain. It was kind of first done as a preprocessor, and then it kind of, went from there. But the whole time they were sort of coming from C and adding features to C++ in ways that were easy for them to implement under the hood. It wasn't really the case that they started from scratch with C++ and implemented each feature the way that maybe it would most optimally be. So what they decided to do to make this work with the C-style linkers was to basically allow you to write this, and then the compiler would sort of silently go in and generate a name for this function based on its arguments. So, you can imagine coming up with sort of a coding system, right? Which is whatever the type is. Like if the type is int, then maybe we append _int, right, to the name of the function, right? And it looks like that, right? So this is foo _int int, this is foo _int. So now we kind of know when we generate a call, we can actually output actual calls in the object file that the linker will look at. We can actually output one that's an actual name that the linker can resolve directly, right? And so that is what this name mangling was all about. This name mangling was about taking things that were potentially overloaded functions in C++ and mangling them into something that would be unique and work with a regular linker. So you can kind of see these sorts of things ending up happening. I'll try to find a good example of one of them. I'm not sure what the best example would be in C. So, this kind of a thing, right? These sorts of things are what I'm talking about. This stuff after the at, that sort of thing there, right? All of that is basically code that tells, it disambiguates this function from another function that may be the same thing but overloaded. Now, because C++ doesn't actually know how overloaded a function might be, because you have to remember C++, usually you compile in multiple files. We're using one big translation unit, but normally you compile files separately. So it doesn't know how many overloaded versions of a function there might be. So it can't only mangle the names of overloaded functions, it has to mangle the names of all functions, because that same function might be defined with a different set of parameters in a different file that's going to get compiled separately. So it's going to be a different translation unit, and only the linker will ever see them together. So even stuff that isn't overloaded has to go through this name mangling, and that's why those things look like they do. So hopefully that makes some sense. All right. So basically that's all I wanted to show today, was just to kind of get our build kind of in some shape there. And then I think the other thing, maybe we've got a few minutes left. I'm going to start today on the thing we're going to do tomorrow, finish up tomorrow, which is we never did our keyboard input. We never wired keyboard input up to the controller, and that requires a little bit of sort of finesse and factoring here that we need to kind of do, because if you remember properly, we did the work of getting keyboard input, right? But we never actually went and wired it up the way that we wired up the controller. So if I go in here and run the game, right, I don't actually, no matter what I do, I don't actually get any actual motion there out of pressing the keys, which I kind of wanted to do. So what I think we can do in our last 10 minutes here, now that we finished with the build stuff, is just think about how we're going to do that. Now, I have a problem, which is that because of the way Windows forces me to go through callbacks, I have no context when I hop in here. So I'm either going to have to use a global variable or use some local storage on the window to figure out where even stuff is, right? Because I need to stuff this stuff into an input structure of some kind, and I don't even know where I'm going to be able to do that, right? What I would like to be able to do is I'd like to be able to parse those messages in my loop here. And so one question that I might ask myself is, could I go ahead and process them there? Because as we know, most of the time Windows actually does send us our messages through here, so it may be possible to just always do the message processing in there. So what I could do, and I'm just going to do this as a test for now, what I could do is go ahead and say these 4 messages that I want, the sys key up, sys key down, those sorts of things, right? I know they're getting dispatched in here. Well, could I do something like this, basically. If the message type, right, if message, right, in fact, I can just do this as a switch statement. If the message is one of these things, WM key down, any of these sorts of things, I'm just going to see what happens if I field it there, and then if there's anything else, if it's something else that comes in, I'm going to go ahead and field it using the standard translate dispatch out to the window routine. And then in here, I'm going to use that assertion that we did to say no, just to see if we got there, right? So I'm going to go ahead and see if that ever fires. So what I'm doing here is I'm testing to see if the keyboard input ever comes in through a path other than the standard loop, because we know that paint messages do, but we don't actually seem to see. So I don't see that. I'm never hitting that. I'm never hitting that assertion, which tells me that we should probably be safe to just move this handling down there. So I'm going to leave this in here. Keyboard input came in through a non-dispatch event or message, and that's bad. What I'm going to do is I'm just going to move our handling out of here, out of the Windows code where we don't actually want to do it, down into the main loop where we process everything else, because that'll be nice and convenient, and I don't have to do any.
Okay, I think I can skip that because I think I've already done it. Yep. I get the key release and then just pass it to the renderer. I think right now I don't do anything with the input. Do I? Oh yeah, I do. Oh yeah, I switch. Nice. Okay, perfect. It's already sorted. Okay, I think I can call it today there. What's tomorrow? Okay, I don't have a gamepad, so I think I might watch a bit of it and then go to video frame rate. But I think at some point, yeah, I think this might be the first thing to do. I need to be able to play audio. I think I put it off for like quite a long while now. I mean, it could be easy, to be fair. We'll find out. Okay, I'm gonna call it today. What the fuck's that? Oh yeah, I can remove that. Still works. Hey, thank you for hanging out, Fluffy Unicorn. Good luck with your engine, and I shall see you later. You have a good day. See ya.